Hello and welcome to LuckyMath. I'm looking forward to introduce you to the inverse function of an exponential function, which is the logarithm. And to do this, I'm going to quickly repeat what inverse functions are. So suppose we have the function f of x, where the argument x is in some arbitrary domain a. Then g would be the inverse function of this function if it takes you back exactly to the argument x. And it is not always the case, but in the examples that we're going to look at, if you have this same function g of some argument y, where y in this case is in some arbitrary domain b, then it would also be f that is the inverse function of g, and it will lead you back to the argument y. So let's do an example, and suppose f of x was x squared. Then what function g would be the inverse function of x squared and would lead you back to the argument x? And you will say, it's obviously the square root. So let's try. If you apply the square root to this function, you will get back to x. But it is important that you have the restriction on x, that it is only in the real values which are greater or equal to 0. Only then the square root really is the inverse function of x squared. And I'm going to do a separate video on this, which is going to appear up here. Now let's say we have the function square root of y, where in this case obviously y has to be in the real values which are also greater or equal to 0, because the square root can only be taken by such values. Then what function would you have to apply to this one in order to get back y? And yes, you would have to square it. So not only is the square root the inverse function of x squared, but x squared is also the inverse function of the square root. Now let's try if f of x was an exponential function, so a to the power x, where now the argument x can be any real value, but we have a restriction on a which says that it should be real but positive and not equal to 1. If you don't understand these restrictions, check out this video up here. Then the question is, what function g, what inverse function would you have to apply to this function in order to get back the argument x? And it is not the square root, but it is the logarithm. If you apply the log to this same base a on this exponential function, it will take you back immediately to x. Let's do an example. Let's say the base a is 2. So 2 to the power x. You would have to apply the log to this same base 2, which is already in the exponential function. To this function, it will take you back to x. Pretty handy, right? So now let's say we have already the log to any base a of y, where we have the restriction on y, and you will see later y, that it has to be greater than 0. And for a, the base a has the same restrictions as the exponential function base a. So what function would you have to apply to this one in order to get back the argument y? And yes, you would have to apply the exponential function. So if you take the log to this base a of y into the exponent of a, it will take you back to the argument y. Let's try this same example, and you would see that 2 to the log to the base 2 of y is equal to y. Now the next step I would like to take is to graph the logarithm to any base a. And to do that we need a coordinate system, so let this be f of x. then this would have to be the x-axis. And the function a to the power x would look approximately like this. And now there is a simple trick to get the inverse function, so the graph of the inverse function, which is to draw the identity map in red. No, it doesn't have to be in red, but I do it in red. So this would be the identity map x, which is just a line at 45 degrees angle from the x-axis. And you will get the inverse function, the log to the base a, if you mirror this original function at this particular line. And you will see that you will get this function right here. So this would be the log to this same base a of x. And since you know that a to the power x always crosses the y-axis at the value 1, now you know that the log crosses the x-axis at the value 1. And since you also know that a to the power x maps all values on the x-axis, so all real values, to only positive values on the y-axis, because it approaches the x-axis, but it will never cross it. Now you see that the log approaches the y-axis, but it will never cross it. And therefore the log is a function from only the positive values on the x-axis, which you can see here. So it only takes positive arguments and it maps them to all values on the y-axis. So thanks for watching, rate the video, subscribe, and see you soon again when I say welcome to Lucky Math.